Solving equations, approximate solutions, part 2. We're solving for x. We want approximate answers, so from the calculator. We want all of them, and we are working in radians. Step A is finished. This already is in the right format. Sine x equals -1/4. Great. We can move right into step B. That requires an accurate picture. Where can I find angles with a sine ratio of -1/4? Well, not in the first quadrant and not in the second quadrant, only in the third and fourth quadrants. So I'm going to have a third quadrant angle with a sine ratio. Sine is opposite over hypotenuse. And then I'm going to have a very symmetrical fourth quadrant angle as well. Same picture, opposite over hypotenuse. So one of my answers is right here in the third quadrant. The other one is a very big angle right here in the fourth quadrant. These are not special triangles, so I have no way of doing this by hand. Obviously, I'm going to have to go to the calculator. And I'm sure you know what we're going to type. We're going to type sine inverse of -1/4. Let's do that, and then we'll try to make sense of what the calculator is telling us. I'm in radian mode. I'll just type it in, sine inverse -1/4, and I end up with about -0.253 radians. Now the question is, which of my two angles did I just find? And the answer is obviously neither one. These are both positive angles. This is a positive angle in the third quadrant. This is a positive angle in the fourth quadrant. The calculator gave me a negative angle. What's going on? Well, again, it's about those limitations. The inverse sine function only knows about angles between -π/2 radians and +π/2 radians. So you know what the calculator gave me? This little fourth quadrant angle, but rotating around in a clockwise direction. This is the -0.253. So how will I find the two angles that I want? Well, the fourth quadrant angle, which I'm going to call x1, the bigger one, that's pretty easy to find. I mean, I already have a name for it, -0.253. It's just not the right name. Well, all I have to do is rotate around another 360 degrees, another 2π, and I'll be back at the same spot. In other words, if I take that sine inverse -1/4 and simply add 2π to it, that's going to give me what I want. So back on the calculator then, I'm just going to type plus, because the calculator understands I want to use my last answer, the sine inverse -1/4 answer, and then add on 2π, and that gives me 6.031 radians. Another way that I could have written that down is I could have said, well, that large angle almost goes around a full 2π radians. It's just a little short by that 0.253. And if I had done that, I would also have obtained 6.031 radians. So what about my third quadrant angle, the one I'm calling x2, the smaller one? Well, it's all about the symmetry of the picture. It's all about the triangles. Where else can I see this 0.253 radians? Obviously, it's this little angle as well, 0.253. So x2 would be rotate around pi and then go an additional 0.253. 180 degrees and then a little bit more gets me what I want. So on the calculator, I will type pi plus that 0.25268 number. I want to type in a whole bunch of digits so I'm not rounding in the middle. And I get 3.394 radians. Well, these are the two answers within one period of the sine function. We wanted all the solutions, so I will need to do step C, but that's easy. Simply take your two answers you found and to each one add multiples of 2π. So plus 2k pi on that one, and then plus 2k pi on the other one. Here then are the infinitely many solutions to this equation. Thanks for watching.